Hi guys, we have a GCE question here that is giving us a diagram that is having a composite shape, that is a circle and a triangle kind of combined together. So the question might look a bit daunting at first, the GCE question, and this GCE that was written very recently, but it's not really too hard. And one thing we should take note from this question is the fact that they said MT is equal to NT, and that they're referring to the lines NT and MT. And you can see, to illustrate that on the diagram, they put two kind of parallel lines to show that those two points are respectively equal to each other. So how do we solve this? Now, the first thing we have to do is to do a little construction. We're going to join N to M. So when we do this construction, we get two shapes. We get an isosceles triangle outside the circle, and inside the circle we have a cyclic quadrilateral. Now, why is it isosceles? Remember, they said NT and MT are the same, and an isosceles triangle has two equal sides. So what does that mean? It means we can use the properties of these shapes to solve this question. Now, we can find the base angles of the isosceles triangles, which are going to be equal from properties of an isosceles triangle. But we also know that the sum of angles in a triangle gives us 180. So we can say N is equal to M from isosceles property, and we can now find the base angles by using this method. We'll subtract 14 from 180 and divide by 2, and we get 83. So N is 83 and M is also 83, as you can see in the diagram now. So we know that from angle on a straight line, as you can see, RNT is a straight line. We can also find the interior angles at N and at M respectively, so that we can get all the angles inside our cyclic quadrilateral. When we subtract this 83 from 180 via angle on a straight line, we get 97 degrees. So we can say that N is 97 and M is also 97 inside the circle or inside a cyclic quadrilateral. Now, from circle theorem, if you know circle theorem very well, you know that there's a property that says opposite angles of a cyclic or in a cyclic quadrilateral are supplementary. So that is what we did here. This is a cyclic quadrilateral property, and if you solve these two equations, you're going to get your x to be 35 and your y to be 16. Thank you for watching.